Hey, my name's Lucas. My project 3.4.2, the R2R Ladder. So this project has kind of three main parts. First is this actual R2R ladder right here. This is the sample and hold circuit, and finally the comparator and final LED output. First, I'll be going over the R2R ladder, the sample and hold, and then I'll cover the final output. So first, the R2R ladder. Here, these resistors are 10.2 k ohms, and these horizontal ones are 5.1 k ohms. These are 1% tolerance, and it's specific because these have to be exactly half the value of these to work properly. You can see on screen is the full circuit diagram of this project. Since normally AND gates would be the input to these resistors, but since we haven't built that part of the circuit, I'm just using these dip switches. Let's see if I turn them all off and plug the DMM into the final output of the R2R ladder. See, it's 0.3 millivolts, or basically zero. This R2R ladder works. First of all, I turn on this switch. This is the most value, and the final output will change to 2.4 volts, or exactly half of the input voltage. The R2R ladder is pretty cool because if I turn on this next switch here, the second switch, 1.2 volts, or exactly half of this first switch. This keeps on going. The next switch, 0.6. Next one, 0.03, or 340 millivolts. See, if I turn them actually all on, they're 5 volts, or about 5 volts. The battery's a little bit low. That's pretty much how this works. Actually a voltage divider, so you can manually set the voltage output here at different intervals. Next, moving on to these two chips over here. The first is the sample and hold circuit. This circuit is pretty much the output of this potentiometer, but that's forgetting the hold part. For example, if I plug the DMM into the output right here, shows 2.1 volts, which for a 0 to 5 volt potentiometer seems pretty accurate, especially since this is about half. But it's pretty unique. If I turn it, the output voltage doesn't change at all. Interesting. This is at its lowest value. It only actually updates if I press this button over here. It updates 20 millivolts, basically zero. The opposite of that, you see it doesn't change at all. If I turn this to the max, press the button, 4.7 volts. Basically, it takes the value. How this works is this button opens up a channel inside of this circuit. Once the channel is open, whatever value this potentiometer is outputting can go into the circuit and is saved in this capacitor. However, once this button's turned off or stops being pushed, that channel closes, and the output, this channel is closed here, and the only output is from this capacitor right here. So once this channel is shut off, no matter what this potentiometer is outputting, the final output from the circuit remains the same because the capacitor saves the last red voltage. Last chip in this circuit is this simple comparator. On the negative end, it takes the R2R ladder, and on the positive end, it takes the sample and hold circuit. This means, because the negative and positive means that if the sample and hold is greater than the R2R, this light will turn on. See here, the R2R is basically it's completely off, 0 volts. So whatever this is at is pretty much good. Right now, it's at 6.7 millivolts, which is pretty much zero, but see it's fluctuating so much. If I change it to 2.8 volts, sample and hold is greater than the R2R, so the LED turns on. Opposite of that, if I turn this all the way up, see here, it's at about 5 volts. That at 5 volts is more than 2.7 volts, so the LED turns off. Well, that was my project 3.4.1, or 3.4.2, sorry. Thanks for watching.